Okay, we're going to go on to section 8.6 on function notation. Now, we talked a little bit about functions back in section 1 of this chapter, in the first lesson. So what we're going to do is expand upon it a little bit. Remember about how no element of the domain can map or correspond to more than one element in the range. That was the idea of a function. But now we're going to look at notation that goes with functions. And all of these linear equations that we've been dealing with that have two variables, x and y, we're going to think of them as what they really are. And that is, they are functions. Okay, so we've been writing slope-intercept form. We've been writing the equations of the lines that look like this, where we have y equals 2x plus 3. Function notation replaces the y with this weird looking notation that looks a little bit like f times x. But this is read f of x. We use this notation instead of the y. So we're going to replace the y with f of x, and if we do, there's our guy. That way we have a name of the function. We know what our independent variable is, what we're plugging in for, and we still have all the information that we had before. Now the advantage to this is that if I say, okay, I want you to plug 5 in up here. We can plug 5 in, do the arithmetic. I want you to plug 3 in up here. We can plug 3 in, we can do the arithmetic. But when we get our answer is going to be a number. I want you to see how this is a little bit better when we use function notation. There's an advantage. Now in the same function as before, we're going to let f of x equal 2x plus 3. The name of our function is f. F of x is the y. F of x is not the name of the function, f is the name of the function. Okay? We're going to find f of x when x is 3. So we're going to plug 3 in for x, but look at what I'm going to do. I'm going to write f of 3 equals 2 times 3. See how I plug the 3 in, plus 3. That way, when I do the arithmetic, and of course this is 6 plus 3, which is 9, I not only can look at this statement right here, see what the y value is, the f of x value is 9, but I know what I plugged in because I'm looking here to see what my independent variable represented. In this case, it represented 3. So I can see all that information in one line. Now, if I had the old notation, I would just have written down y equals 9 instead of the function notation if I use the y. But if I write this out, I can write f of 3 equals 9, and there's the advantage. Somebody walks in that hasn't been in the room watching me work these problems out. I say y equals 9. They don't know what I plugged in unless they go back to read through the problem. But here they know exactly what I plugged in. So there's the real advantage to function notation. One of the real advantages. That we can name functions differently. We don't always have to have y equals this, y equals that. We can use f of x or g of x or h of x and give it all sorts of different names. Here's an example where we're going to substitute in some values. It says let g of x equal 4x minus 5. Now the name of the function is g. Remember, this is our y equals 4x minus 5, slope-intercept form. We're to find the indicated value. I have 3 different kinds of problems. One like the last one, where I'm finding g of x when x is 2. So I'm going to be finding g of 2, which would be 4 times 2 minus 5. It's a little sloppy. 4 times 2 is 8, minus 5 is 3. And I have that value. Or here, look at the convenience of writing it this way as compared to this. I know exactly what x is, so this is going to equal 4 times negative 10 minus 5, which is negative 40 minus 5, and that's like adding the opposite, that's negative 45. Now, a little different here, instead of plugging in for x and finding my g of x or my y value, here they give me the y value. They say g of x is equal to 19. So I don't have a lot of space here, so I'm going to come up here. I'm going to plug a 19 in for g of x. Not in for x, in for all of it. So I have 19 equals, the rest here, 4x minus 5. And I have an equation like I had back in first semester. I'm going to add 5 to both sides. And I'm going to get 24 equals 4x. Then I'm going to divide both sides by 4. I'm kind of combining steps here because I don't have a lot of space. And 24 divided by 4 is 6, so I have x equals 6, and that's my answer down here, x equals 6. Okay, let's now look at what we have here. We have another example, very much like the last one, because it's really important you get this concept down. We're going to go through another example. It says here, let f of x equal negative 4x minus 6, find the indicated value. And they want you to find f of x when x is equal to negative 2. Remember, that means f of negative 2. That's what's plugging in for x. So negative 2 in here. Careful of all those negatives. Could get confusing there. Negative 4 times negative 2 is positive 8 minus 6. No, not so bad. So it looks like f of negative 2 is equal to 2. Next one up. We're going to find x when f of x is equal to negative 6. Now in this case, this is my y value. This is what I'm going to plug in here. Not in for x, but in for f of x. I'm going to put negative 6 equals negative 4x minus 6. Now I'm going to solve this equation. I'm going to add 6. I'm going to do the minus 6 here. I'm going to add 6 to both sides. So that's 0 equals negative 4x. Divide both sides by negative 4. And up here, 0 divided by negative 4 is 0. So I have x is equal to 0. So that's what I have on that one. Then, let's see, I'm going to graph 3 linear functions. Notice using the function notation. Remember, f of x, g of x, h of x, that means the same thing as y. And all of these are pretty much in slope-intercept form. The slope here is negative 1/2. My y-intercept is 0, 2. Right here, 0, 2 on the y-axis. Negative 1/2, I'm going to think of this as negative 1 over positive 2. I'm going to go down 1, right 2. And I have my second point. I would grab a straight edge, and I'm graphing my line to go through those 2 points. Over here, slope-intercept form, just function notation. Slope is 3/4, y-intercept's down here at 0, negative 2. Positive 3/4 means up 3 from the y-intercept, up 1, 2, 3, to the right 4. Got my second point there. Oops, make that a little bit bigger. And that's why you use a straight edge instead of freehanding it. Now the last one looks a little unusual because we haven't done one like this for a couple of lessons here. But there is no x variable here on the right side. It's just negative 1. Well, that means that the number in front of the x is 0, 0x. That would disappear, and I would just have the negative 1. That means this has slope 0. It's a horizontal line. Horizontal lines have slope 0. So through the negative 1, there's my y-intercept at 0, negative 1, I draw a horizontal line that goes through that point. And even though it's the most unusual looking, it's probably the easiest one to do. Now the last example brings into the idea of what we were doing before when we were writing equations and function notation at the same time. It says write a linear equation h given that h of 0 equals 10 and h of 4 equals negative 18. We've never had the information presented quite that way because of the function notation, but h of 0 means x is 0 and that's my y value. My y value is 10, so I have the ordered pair 0, 10. And I have the ordered pair, see the x here and the y here, it would be 4, negative 18. So the linear equation is easy now. In fact, that's my y-intercept because the x value is 0. I need the slope. So the slope formula, once again, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. I'm going to plug in these values. I'll call this x1, y1. I'll call this x2, y2. And I'll plug those 4 numbers in. I get negative 18 minus 10 all over 4 minus 0. Careful there, subtracting. That's like adding the opposite. So that's negative 28 over positive 4. My slope is negative 7. That's m, and that's my b. So instead of writing y equals mx plus b, I'm going to write h of x, because my function's h of x equals mx plus b. And I'm going to plug those numbers in. This in for b, this in for m. So I have h of x is equal to negative 7x plus a positive 10. And there's my equation using function notation. So it's not bad, it's just a little different, a little bit to get used to, and you will as long as you practice, practice, practice.